Hi there students, it's Mr. V. Today what we're going to do is we're going to study an introduction to linear perspective, and what that is the illusion of three dimensions. Your essential questions for this lesson are, what is linear perspective? Also, you need to know the tools. What is a horizon line? What is a vanishing point? And what is the x-axis, the y-axis, and the z-axis? Linear perspective can be a challenge for art students because there's not very much creativity or expression involved at the beginning. It's almost like math, and because of that, it can be a big challenge to some students. Some consider this to be the most difficult lesson out of the entire year, so I encourage you to go back and study. We'll go over several demonstrations as well, but just know that your practice and your study will determine your success in this unit. Ultimately, it's up to you. In case you need help, I am always here. So what is linear perspective? Linear perspective is the illusion of three-dimensional depth on a two-dimensional surface. Your paper is two-dimensional. All it has is height and width. But in 3D, you've got height, width, and depth. So how do you capture that on a flat surface? Well, what you do is you use a variety of tools to fool the mind into thinking that it sees a three-dimensional form. For it to even work, it has to be done correct. That's why it's compared closely to math. Well, if you have three-dimensional depth in your work, it makes it believable to your viewer. For example, this big jug, if I were to draw this bad boy, it would be believable if it looked in 3D. If it was flat and we couldn't tell if we were looking up or down at it, it would look like a sticker. So you need to convey height, width, and depth in the things that you draw. Whether it's a nature scene, whether it's a bunch of cubes like what we'll start learning with, or whether it is a still life, something you're drawing in front of you. Even a portrait of a person's face uses these tools that you're about to learn. And at the beginning, we learn with mostly cube or rectangle-like shapes with 90-degree angles on them. After you get that down, then we start to work on curved and rounded forms in 3D. So here's an example of student work that uses linear perspective. It uses the tools and the rules of three-dimensional illusion in your work. It fools the brain into thinking that we're at a high level and we're looking down above buildings and such. This student achieved success because he studied. Here's an example of work that did not use the rules of linear perspective. As a matter of fact, unfortunately, this student was one who didn't come to class much. So when time came for the project, he failed miserably. So using the rules will determine whether or not you pull off the illusion or not. Now, doing this isn't difficult. It just involves the study and knowing how the tools work together and why you would use the tools and what function they have. And since the rules for linear perspective don't ever change, that means they are learnable and that you can master them. So there will be a threshold that you have to reach in your learning to get good at it. Let's go over the tools. Each of these tools need to be used together in order for it to work properly. If you ignore one, the whole piece will fall apart. Let's look at the first tool, horizon line. The horizon line represents your eye level, your height in the piece. The horizon line is an imaginary symbol. It doesn't exist in the drawing at all. The horizon line is also the foundation for the entire illusion in your work. This is an example of several cubes drawn in one-point perspective. If we look over here to the left, the stick figure represents you in your virtual world on the paper. Anything above this line we will be looking up at. Anything below this line we'll be looking down at. We'll see the top of it. And anything that is intersected by this line, meaning it rests on it, we will neither see the top nor the bottom. Here's the other cool thing about a horizon line. Since it represents how tall you are, whenever you draw something in 3D, always compare your height to it. For example, most stop signs are pretty tall. They're taller than your average person. If our horizon line were to line up on the stop sign that's closest to us, that would represent how tall we would be compared to that stop sign. If we existed in a flat world, like just completely flat ground, and we put 4 stop signs off in the distance, they would start to get smaller. But here's the thing, wherever that horizon line crosses that stop sign, it's still going to be the same because it represents how tall we are in our piece. That's one of the ways that you create the illusion of depth. You make things bigger and smaller, and then you use your horizon line to make sure that it's consistent in where it's put. Not using the horizon line means that everything in your piece will be inconsistent. We'll be seeing the top of a form when we shouldn't, or your piece will look flat without any depth. We can tell that the horizon line is right about here in this image, because there's a point where things stop being up above and down below. The horizon line is how tall the camera was in this photo. We can actually tell how tall the photographer was based on where the horizon line falls within everything here. So when you draw in 3D, always use your horizon line to help you gauge how big things should be next to each other. Now, where you put your horizon line in your piece also matters. Most beginning students, when we're learning how to use cubes, we usually put the horizon line in the dead center of the page. But as you get better, you'll notice that you'll want your horizon line to either be up at the top or the bottom of your paper, depending on what you want to show off. In this image, the horizon line is down near the bottom. We see more of the sky. Likewise, if you want your viewer to be way high up and we're looking down on things, you want your horizon line to be pretty high up because everything below the horizon line is beneath you. All right, let's move on to your next tool. Your next tool is called the vanishing point. The vanishing point is an imaginary symbol, and it's used to calculate depth and distance in the piece. Now, your vanishing point always sits on the horizon line. In class, you're going to hear me use the phrase VP. That's because I always abbreviate vanishing point VP. You'll usually hear me say VP1, VP2. Any plane or line that's in 3D, that's like receding off in the distance, that always lines up to a VP. And anytime there's something receding off into the distance, it lines up with that vanishing point. It gets sucked into it. Here in this image, we see that the railroad tracks converge on a vanishing point. We also see that the top of all the fence posts, if we were to connect the line through them, converges on the vanishing point, as well as the bottom of the fence posts. Also, the street does the same thing. Now, another thing to know about vanishing points is that there can always be more than one VP. There are two instances where that'll happen. The first is if you have an object in your drawing that's lined up a little different than everything else, like a door that's open. If this table were crooked at a different angle, slanted, it would need to go to its own vanishing point because it doesn't line up with everything else. So you'd need two vanishing points, one for everything against the walls and in the room, and then one for the table going off in the distance. Now, the second time you'd have more than one VP would be if we're using more advanced levels of linear perspective. You'll learn 1 and 2 point perspective. All right, let's go to your next set of tools, the X, the Y, and the Z axis. Now, if you've had geometry, you already know how to do this. You already know how to plot coordinates on a graph. It's the exact same principle in linear perspective. The x-axis only exists in 1 point perspective, and it represents any line or plane that is left to right, horizontal, flat. Here's an example of a cube in 1 point perspective. The x-axis would be any line that's left to right. But just for you know, in every other form of linear perspective, outside of 1 point, this is an example of 2 point perspective right here. There is no x-axis at all. Can't find any flat left to right lines. There's just straight up and down or slanted. All right, let's look at the y-axis. It represents all up and down vertical lines and planes. Up and down lines, all vertical lines that you see in this image, that's y-axis. Every corner of the countertop, every edge of a booth, every side of a chair, and edge of a lamp, and so on. The z-axis. You likely haven't learned a z-axis yet in math, but the z-axis is used in every type of perspective. 1 point, 2 point, 3 point, and everything else. The z-axis represents any line or plane that is receding off into the distance that looks 3D. The z-axis is also always connected to a VP. Let's take a look at some z-axis. These lights here that recede off and converge at a vanishing point, that is the z-axis. If I were to draw a line connecting the edges of each one of these chairs, for example, from the corner here and on down, that would be a z-axis as well. This whole wall in the inside of the rail car, that's on the z-axis. The rails that converge to a VP, z-axis. Fence posts, yes, they're on the y-axis individually, but they line up on a z-axis because they recede off into the distance. So, you heard me say it earlier, you're going to learn different types of linear perspective. You'll learn 1 point and 2 point. Let's look at 1 point. 1 point makes objects that are facing directly at you, it makes them look three-dimensional. You see each one of these chairs, if we were to run into it, we would smack into the front face of it. And because there is an x-axis, things are flat. Just like a rectangle, a normal shape. You would plow into it almost like hitting a wall. Here's an example of a town in 1 point perspective. We see the front of the building and the slanted sides of the building receding off into the distance. X-axis, y-axis, z-axis. It's great for alleys, streets, letters, graffiti. 2 point perspective does the exact same thing that 1 point perspective does, except it makes things look 3D at an angle. You can see more sides of your subject than you could in one-point perspective, and therefore makes it more believable. In two-point perspective, everything's at an angle. There are no flat edges facing you directly, only sharp corners. I find two-point perspective to be way easier than one-point perspective because it draws itself, in a sense. Also, the major difference in two-point perspective, no x-axis whatsoever. There are no left to right horizontal lines. There are simply vertical lines and slanted lines. That's it. And work in two-point perspective, again, it looks more realistic. You see more of your subject. Here's a sample of different types of perspective. Here's three-point perspective. What three-point does is it gives the illusion of depth, but also height as well. There's also what's called five-point perspective, where you've got a vanishing point at the north, south, east, west, and then one in the dead center, and it makes things look like you're looking through a fishbowl. That's a lot of fun. Perspective can also be used in creative and interesting ways to give the illusion of three-dimensionality in real life. This is a pencil sketch that was done on 2 pieces of paper. Same thing with this image right here. This is done in all pencil. It's also the secret to how this sidewalk chalk artist gives the illusion of three-dimensionality in his piece. Now this is a two-dimensional drawing. It's flat on the concrete, but it looks 3D. It's because he used a horizon line and different vanishing points. Here's an image of a globe sitting on the sidewalk itself. It looks 3D, like it's sitting up on there, and that the artist off in the distance is standing on it. But if we look at it from the side, this is what it actually looks like. It's an illusion. It's just using tools to give the illusion that something looks like it actually does not. So that's an introduction to linear perspective. We'll get more specific in the future, and we'll do lots of demos in class as well. So answer the questions at the end of the lesson, and I look forward to seeing you in class.